Problem 50. Use an orbital diagram to write the electron configuration of each element whose location is shown in the periodic table. So you got several elements here. Now the orbital diagram that this problem mentions is actually figure 2.8 in the textbook. So this figure has a bunch of boxes in there, and each box is connected with an arrow. Okay, so you know the arrows go in this direction. You start at the bottom, and then there's an arrow that leads to this box, and an arrow that leads to that box, and an arrow that leads to that box. So what this is talking about is each box represents an orbital that electrons reside in. So the nucleus of an atom is surrounded by many electrons, and these electrons occupy orbitals. And in this diagram tells you what orbitals there are that surround the nucleus, and also which order they're filled in. So each box represents an orbital, and the rule is 2 electrons per orbital. So if you have an atom with many electrons in there, then 2 can go in this one, 2 can go in that one, then 2, 2, 2, 2, 2. And eventually, if you have an atom with, say, 11 electrons, so you have 2, 4, 6, 8, 10, and then the 11th one will go there. Okay, so that's the order that they fill in. 2 electrons per orbital, and the orbitals fill from the bottom up. Now, you can watch the lecture videos for more information, but just a little bit more. You have 4 different types of orbitals. You can see, these are the S's, these are the P's, these are the D's, and these are the F's. And this is kind of what they look like. Okay? Now, imagine the nucleus of an atom is surrounded by all of these orbitals. Okay? So let's take a look at these particular elements. Okay, so what is this one right here? Element D. All right, let's put A. A. So let's move this up and kind of light A here. And so let's do A. So what element is A? Here's where we got to break our periodic table out, because it doesn't show us what these elements are. So let me show you the periodic table. No, not that one. This one. Okay, so that's this guy right here, right? That guy right there. So that's the nitrogen. Nitrogen is element number 7. Okay, so I'm going to put nitrogen. Okay, it's element number 7, and that means 7 electrons. Okay, now the way we do this, we need to put 7 electrons. So remember, 2 electrons per orbital, and we work our way up. Okay, and follow the arrows. So 2 electrons go in the 1s orbital. Okay, so I'll put I'll write it in blue. So 1s 2. So, there's the 1s orbital, 2 electrons on in that 1s orbital. If you want, you can fill an orbital diagram as you go. So maybe we'll do that here. So imagine 1, 2. Okay, really they got arrows. So one is spinning up and the other one's spinning down. The electrons have spins. Okay, so how many more electrons do we have to go? We need to put 7. Okay, so we've already put 2. And then 3, 4 are going to go here. So 3, 4 go in the 2s orbital. So we write 2s2. And then 5, 6, 7. So these 2p orbitals are going to get 3 electrons. Now, when you fill orbitals of the same type, of the same subshell, You know, these are all 2p orbitals. They all look like that. They're just pointing in different directions. The way you would do it is one would go here, one would go there, and one would go there. They're all kind of spinning the same way. That's not too important, but what's important is you have 3 electrons in the 2p orbitals. And so to finish the electron configuration, we would put 2p3 in there. That's electron configuration that we got by use orbital diagram. So we started at the bottom and we worked our way until we got to 7 electrons. Now what's the next one here? B. Wow, that's kind of far down there. Let's do D. Okay. D. So where is element D here? That's is that titanium? That's right there, right? Right there. That's titanium, element number 22. So 22 electrons, and we have to do the same thing. We start at the bottom and work our way up till we get to 22. Okay, so we can just continue on with the way we've done it. So 2, 4, 5, 6, 7, and then go back and pair them. 8, 9, 10. Now those are filled up. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21, 22. You see how we followed the blue arrows? And we ended up in 3D. So the electron configuration is going to look like this here at the bottom. So, we can just look at this box. So that's 1s2. So 1s2. You got 2 electrons in the 1s orbital. And then we got 2s2 and then 2p6. 6 electrons in the 2p orbital. So 2s2, 2p6. And then going into these third shell, 3s, 3s2, 3p6, 3s2, 3p6. Okay, now you might want to jump to 3D because it's, number 3, third shell, but actually the 4s gets filled before the 3D. So you say 4s2 and then 3d2. 4s2, 3d2. And that's the configuration for titanium. Now we'll do one here. Which one? So we did that one. We did this one. How about the hardest one? Let's do B. That's the hardest one. So B is way down here. And what element is that? That's this one. No, that's that one. Okay. So that looks like iodine, number 53. Number 53. So here we'll do B, and this is going to be iodine, 53 electrons. Okay, and we would do this the same way, and where did we end up with? We ended up with 22 electrons, so we'll just continue on, 23, 24, 25. Let's just continue on like that. So let's go back up here. 23, 24, 25, go back and pair them. 26, 27, 28, 29, 30. Done with 3Ds. 31, 32, 33, 34, 35, 36, 37, 38, 39, 39, 40, 41, 42, 40, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53. That was a lot. Okay. So we ended up in the 5p's. So the electron configuration is going to end with 5p5. So starting all the way at the beginning. So here I kind of need two places to write. Here, let's just keep it right there, and I'll copy and paste it. So you can, watch as I write. So starting at 1s. So I'll just put it here, 1s2, and then go up to 2s2. That's those right there, and then 2p6, 2p6, and then 3s2, 3p6, 3s2, 3p6, and then 4s2, 3d10, right? 4s2, 3d10, and then 4p6, 4p6, and then 5s2. I'll run a room here. 4d10, and then 5p5. We didn't quite fill up the 5p subshell, almost, but not quite. And so let's just copy and paste this over here. Cut and bring that down here. And there you go. Okay. So I think you can work out the other ones. We did the hardest one, so you can do those two right here, which would be this one, manganese, and then what's the other one? Gallium. Okay, manganese and gallium.